Hi everyone, Unit 2, Relations and Functions, Section 1, Relations and Functions. This is Chapter 5 of your textbook. So there's a few curriculum outcomes I want you to be aware of. Okay, you'll develop an algebraic and graphical reasoning through the study of relations. You'll be able to demonstrate an understanding of relations and functions. You'll represent a linear function using function notation. You'll determine the characteristics of the graphs of linear relations, including the intercepts, slope, domain, and range. You'll be able to describe and represent linear relations using words, ordered pairs, tables of values, graphs, and equations. So here's the checklist for everything you need to do this section or this chapter. So you should have already done the relations and functions pre-assessment. If you haven't, please stop this video and go and do that now. Okay, after you finish that, okay, there are 6 parts to this chapter. So representing relations, properties of functions, interpreting and sketching graphs, graphs of relations and functions, properties of linear relations, and interpreting graphs of linear functions. There's notes and practice for each one of those parts. Okay, at the end of part 6, you will have a formative assessment. So that's a review assignment for all of chapter 5. Okay, that formative assessments are not for marks, remember. Okay, after you finish the formative assessment, you'll have a curriculum review, which is a summative assignment for the whole chapter. And then, of course, you'll have your chapter quiz. There's no unit exam for this until the end of chapter 7. It's chapters 5, 6, and 7 that represent unit 2, so no big exams for quite a while. So, all right, let's get started. Part 1, Representing Relations. In this lesson, we are going to explore different ways of representing relationships in data. Common ways are lists, tables, arrow diagrams, charts, and graphs. All right, so let's start off with something called a set. So a set is a collection of distinct objects. An element then of a set is just one of the objects in the set. Okay, and then a relation associates the elements of one set with the elements of the other set. Okay, so one way to write a set is to list the elements inside braces or curly brackets. Now, no one is ever going to mark you on how pretty you make your curly brackets. Okay, so just do the best you can. Okay, for example, we can write the set of natural numbers from 1 to 5, okay, as, so curly bracket, 1, 2, 3, 4, and 5, close the curly bracket. So this is a set of all the natural numbers from 1 to 5. Perfect. Okay, the order of elements in a single set, so a single set, doesn't matter. So I can switch the order, so 1, 3, 5, 2, and 4. So this still represents all the natural numbers from 1 to 5. Order in a single set doesn't matter. How about when there's multiple sets? Well, of course, order does matter there, and let's set the stage and show you how. Okay, so consider the set of fruits and a set of colors. Now, we're not going to have all the fruits or all the colors, but we'll just have a sampling of those. Okay, so we can associate fruits with their colors. For example, an apple may have the color red. Okay, so this part, an apple, that's the element of the first set. Okay, then we have some form of association. Okay, so may have the color, and then we have an element of the second set. So this makes a relation. So curly bracket, apple, comma, red is a set of ordered pairs that makes a relation. Awesome. Okay, we can make many such relations with other fruits and colors as shown below. So we can have an apple that's red, we can have an apple that's green. We can have a blueberry that's blue, we can have a cherry that's red, and a huckleberry that's blue. Okay, great. So here are some ways to represent this relation. So that last set was ordered pairs. Now let's try with a table. So we have the headings of each column describes the set. So I have fruit here and then color. So that describes the set of data. Okay, so fruit, we've got apple, blueberry, cherry, and huckleberry. And then the table associates that fruit with its color. So apple can be red. Okay, an apple can be green. A blueberry can be blue. Cherries can be red, and huckleberries can be blue. Okay, so that's how we can represent these as a table. Okay, we can also represent them as an arrow diagram. Okay, the two ovals represent the sets. Okay, so each arrow associates an element in the first set with an element of the second set. Okay, now remember, it doesn't matter what order the things are inside the set. So I could have put apple down here. Okay, it'll just change where the arrows go. It's really not a big deal. Okay, however, you can't change the order of the actual sets. Okay. Let's see. So each arrow associates the element of the first set with the element of the second set. Yeah, we talked about that. So we have the two ovals and then may have the color. So that's the association. Okay, the order of the words in the ordered pairs, the columns in the table, and the ovals in the arrow diagrams is important. It makes sense to say an apple may have the color red, but it makes no sense to say red may have the color apple. That is, a relation has direction from one set to the other set. So see how the arrows go this way for all of these? It doesn't make sense to draw the arrows backwards. Okay, so don't do that. Awesome. There we go. Okay, so order is important for two or more sets. Moving on, example 1. Representing a relation given as a table. Some animals can be associated with the scientific class they're in. Okay, so we have a bunch of animals, so an ant, an eagle, a snake, a turtle, a whale. Okay, and they are in the scientific class, so an ant is in Insecta, an eagle is in the class Aves, a snake is in Reptilia, turtles are in Reptilia, and whales are in the scientific class Mammalia. Okay, so describe the relation in words. Okay, so this relation shows the association. This relation shows the association is in the scientific class. For a set of animals. Okay, so this relation shows the association is in the scientific class for a set of animals. Okay, so represent this relation as a set of ordered pairs and as an arrow diagram. So ordered pairs, so we just curly brackets. So we have an ant is in Insecta. Capital letter, I guess, secta. Okay, so there's our first ordered pair, so then a comma. So an eagle is in Aves. Okay, so bracket, bracket. Okay, snake is in Reptilia. Awesome. Okay, I'll just keep going here. Turtle is also in Reptilia. And lastly, we have a whale in Mammalia. Okay, and then finish up with the curly bracket. So that is the set of data that we have as ordered pairs. Perfect, and then we need to make these in arrow diagrams. So the easiest way to do those is to write all the eagle, snake, turtle, whale. So just, there we go. So draw all the things first and then draw the oval. It's a lot easier than drawing the oval first. Okay, so then we have the class Insecta, Aves, Reptilia, and Mammalia. Okay, we don't need to write Reptilia twice. So an ant is in Insecta, eagles are in Aves, a snake is in Reptilia and a turtle is in Reptilia. So see how both arrows go to that one, and the whale is in Mammalia. Okay, so then we need to put the relation as well, is in the scientific class. Wow, that's terrible writing. I'm sorry. In the scientific class. There we go. Okay, so there's how we set up the arrow diagram. Okay, perfect. Moving on. Okay, example 2, representing a relation given as a bar graph. Okay, so different towns in British Columbia can be associated with the average time in hours that it takes to drive to Vancouver. Consider the relation represented by this graph. Okay, so represent this as a table. Okay, so if I want to change this to a table, okay, so we need okay, all the communities. So we'll label this, so community. Okay, and then the other set of data is the time from Vancouver. So time to drive to Vancouver. Okay. So the community, so we're going to say Horseshoe Bay. Horseshoe Bay. Okay. Lillooet. Okay. Pemberton. Okay. Squamish. And Whistler. Okay, so there's all the communities we're talking about. Okay, so Horseshoe Bay, let's see. So each tick on the graph is half an hour. So that looks like it's between half an hour and 1 hour. So I think it's pretty fair to say, like 3/4 of an hour or 45 minutes. 0.75 hours works as well. Okay, Lillooet, on the other hand, that looks like it's 4.5 hours away from Vancouver, 4.5. Okay, Pemberton, okay, so 2.5 is there, so that looks like 2 3/4 or 2.75 hours. Okay, Squamish, okay, so that's an hour and a half away, so 1.5 hours. Okay, and Whistler, let's see, so that's 1 hour, so 2.5 hours for Whistler. Okay, so that's how we can represent that chart as a table. Okay, and now we're going to represent it as an arrow diagram. Okay, so okay, so Horseshoe Bay. Okay, Lillooet, Pemberton, Squamish, and Whistler. Okay, remember when you're doing an arrow diagram, put all the words first before you make the oval. Okay, and then the other set is 0.75 hours. Okay, 4.5 hours, 2.75, 1.5, and 2.5 hours. Okay, great. So to make that oval there. Okay, and of course, the association here is the time to drive to Vancouver. Okay, so Horseshoe Bay, that was 3/4 of an hour. Lillooet was 4.5. Pemberton was 2.75. Squamish 1.5, and Whistler 2.5. Okay, so that is an arrow diagram for that guy. Okay, so sometimes a relation contains so many ordered pairs that it's impossible to list all of them or to represent them in a table. Okay, so example 3, identifying a relation from a diagram. So in this diagram, so English words has this number of letters. So that's the association, and then we have natural numbers. So we have English words, okay, having so many letters. Okay, so describe this relation in words. Okay, so this relation, this relation describes how many letters are in words of the English language. Perfect. Okay, so list 2 ordered pairs that belong to this relation. Okay, well, tell you what. Let's pick pairs just because it's there. So pairs, let's see, that's 1, 2, 3, 4, 5 letters. So that's an ordered pair that belongs in this one. Okay, how about relation? Let's use that one as well. So relation, 1, 2, 3, 4, 5, 6, 7, 8. So that has 8. Okay, so those are 2 such ordered pairs. Okay, perfect. And really, that's it. We can do more, like ordered or to or this. You can pick words that aren't in that sentence too. Okay, either way, that's how you can make ordered pairs from this. We would never be able to list them all. Yeah, just too many. All right, so we're done this particular part. I want you to practice this. This is section 5.1 in your textbook, starting on page 262. Okay, remember you can either use your textbook or print off the page in the workspace card. Again, I recommend printing off the page just because then you can write all over it, but that's completely up to you. Remember, the answers are in the back of the textbook, so please check them and make sure you show your teacher before moving on to the next part. Okay, good luck. We'll see you next part. Thanks.